In this video, I'm going to go through the process of using RStudio to do some of the calculations involved with linear regression. And to give ourselves context, I'm going to start with a problem that we would answer using linear regression. So here we have a car company that's studying the effect of TV ads on their car sales. So they conduct an experiment in which they choose 10 media markets and spend different amounts on TV advertising in each market. They then track the sales within each market. So we have this data set. For each media market, we have how much they spent on TV advertising in thousands of dollars, and we also have what their sales were in that market in millions of dollars. And our question is there evidence that increasing spending on TV ads results in higher sales? So this is a linear regression type situation, or at least we can't be sure that linear regression makes sense, but it's a regression situation because we have one population. So the population is the individuals, well, the population consists of the same individuals that are in the sample. Our sample is of media markets. So our population is all media markets in the US. And we have two quantitative variables. So we have variable 1, which is TV ad spending in thousands of dollars. And our second variable, variable 2, is sales in millions of dollars. So we're in the situation where linear regression might make sense. We have one population and two variables. And what I'm going to do is I'm going to enter this information into RStudio and show you how to get some of the things that you'd want in order to perform linear regression and be able to see whether linear regression is appropriate. So the first thing I want to do is I want to get this data into RStudio, and it's important that the data I have is in the same order. So if we look up here, this TV spending, the media market where we spent $230.1 thousand, in that media market, the sales were $22.1 million. And similarly, this number 8.6 corresponds to this number 4.8. It's really important when we're dealing with this situation of one population and multiple variables that our variables are paired appropriately. That is, our values for each variable, the order they're written, the order they're entered into R, is the same order for both. Okay, so I have this as a comma separated list, so I'm going to copy and paste it into R. So let's get our TV spending entered. So I'll call this variable TV. It's always good to choose variable names that remind you what the variable is. And then I'll copy and paste this sales variable, and I'll call it sales. So now that I have these numbers entered into R, the first thing I'm going to do is I'm going to make a scatter plot of these two variables. Now, if we're making a scatter plot, we actually have to make a decision, and it's not always the easiest decision. In this case, there's definitely a right choice. We need to decide which variable's X and which variable's Y. And there are a few ways that you can make that decision. The two main reasons that you would decide which one's X and which one's Y is whether you're trying to use one variable to predict the other. So if we're trying to predict a variable, that should be our Y variable. And the variable we're using to predict should be our X variable. And the second reason would be if you think that one variable is causing the other variable to change, in which case you would want the explanatory variable, the one that's causing the variable to change, to be X, and the variable that's being caused to change would be Y. In both cases in this problem, no matter how we're looking at it, the TV spending should be X, and the sales should be Y. And the reason for that, if we look at both situations, is it makes sense to try to predict sales based on TV ad spending, because you get to choose how much you spend on ads, and then you have some amount of sales, and you might want to make a guess of, if we're targeting certain sales, how much should we spend on TV ads? And it also makes sense that you would think that spending more on TV ads would cause you to have more sales. The opposite things don't work, right? Selling more doesn't cause you to spend more on TV ads. And it also seems not particularly reasonable to try to predict your ad spending based on your sales. So however we look at it, TV, or variable TV, should be X, and sales should be Y. So this is a bit, I already have the graph. We got a bit of a preview. Let's doesn't really matter, but let's clear that graph away from here. When I enter this in, I'm going to enter the Y variable first. So the command is plot, and I'm going to tell it to plot sales tilde TV. And I put Y first and then X second. And if you're wondering why do we do it that way, we had to choose one way or the other, and this is the order it was chosen. I think this is a bit counterintuitive, but luckily when you do this and you get your graph, you can see, and in fact, I guess I've done something I shouldn't do. I should zoom a little bit out on this. Let me show you if you're doing this on your own. It tells me which variable's which. So when I plot these things, let's just quickly resize this so we can see our variables. As long as we look at what's been plotted, we can see if we did this right? So I wanted TV to be the x-axis and sales to be the y-axis. So even if I was unsure of the order in which to type things, I would eventually get the right thing. If I had done it backwards, I would have noticed, oh, wait, this put TV on the y-axis, and that wasn't what I wanted. All right, so we have our scatter plot. So that's one of the big things that we wanted to do using software, right? Plotting stuff by hand, it's doable, but it's a lot quicker to use software. What might we wonder? I look at the scatter plot. I now think that linear regression seems reasonable. It looks like there is some sort of pattern, and the pattern does not appear to be nonlinear. That is, there's not some curved pattern. I think a linear pattern might be reasonable. And given that a linear pattern might be reasonable, one thing we might want to do is find the correlation between sales and TV. And so let's do that. So the command is just COR, sales, TV. And here we see that the correlation is 0.777. So let's write that down. So our correlation is this value that we call R, 0.777. Now you might ask, wait, okay, so you typed sales, TV. What if you had typed it the other way? It turns out that certain things in regression, order of variables doesn't matter, and certain things it does. So correlation between two variables is the same whether or not you put X first and Y second, or Y first and X second. The reason being that correlation describes how strong the linear relationship is, and if we switch X and Y, we still have an equally strong relationship. The graph will look different, but all we've really done is reflected it across the line X equals Y. Okay, so we can find our correlation. It's just this command COR. It's really straightforward to do. The final thing we might want to do is now that we've decided that a regression line seems appropriate, we might want to find the equation of the regression line. Right? Our regression line is going to be of the form y hat equals blank plus blank times x. And we want to know what those numbers are. So to do this, there's actually an intermediate step. And so the first thing I'm going to do is I'm going to tell RStudio to create a linear regression model of our data set. And you can call this whatever you want. I'm just going to call it model. So that's the name of this thing. And the command to get this thing, I type LM. LM, I believe, is for linear model. Parentheses. And again, I put Y first, and then tilde, and then X. So here my variables are sales and TV. And so I want my model to be LM sales tilde TV. I'll click enter. And it seems like nothing's happened. But if you look in RStudio at the list of objects and variables up to the right, you'll see, if you've done this on your own, that model now appears. And now that I've done this, it seems like I've done nothing, but I have to extract the information from the model. So this model contains a ton of information, and I don't actually want all of it, but what I'm going to do is I'm going to get a summary of it, which will include what I was looking for, the regression line equation. So I'll type summary of model and click enter, and it gives me a bunch of stuff. So let's start from the top. So it tells me some stuff about the residuals. I don't really care about that. Remember, software output, you have to recognize that there are things that you, even if you know what they are, you don't want to look at them right now. There's some information about t-values and p-values. I don't really want that right now. What I really want is this estimate column. So everything under estimate is what I want. And the intercept refers to the y-intercept. So that's 7.33. And TV refers to the slope. Why is it TV? Well, it's the coefficient on the TV variable, right? X represents TV ads. And they're calling it TV because it's the coefficient that goes with our variable TV. And so that's 0. Let's say 0.47 if I round to 3 decimal places. And so this is my regression. There's a ton of other information here that we'll use later. We'll use some of this in hypothesis testing. Some of it we'll never use. But the regression line is just that first column, the one under estimate. And it's important to identify which number's which, right? If you flip things around, you'll get something wrong. Okay, so there's a bunch of other information. The only thing that I do want to point out here is this number, 0.6036. And they're calling this multiple r squared. Remember, r squared, when we square the correlation, we get something that we can interpret, right? It tells us the percentage of the variation in y that's explained by the regression line. And you might say, oh, what is this multiple r squared? Well, let's just confirm. We already found the correlation, right? It rounded to 0.77. So let's, or it was actually 3 sevens. Let's square this thing. And we'll see that up to rounding, because I did round this a bit, yeah, we get this same thing. So it actually tells us the r squared value, although we don't need that, right? We can separately find it by finding the correlation. So we've created a scatter plot. We've found the correlation, and we found the equation of the regression line. The final thing I want to show you how to do, which is useful for a couple reasons, is to take this scatter plot that we have and put the regression line onto it, right? So there's 2 reasons to do this. One is it's just a nice picture, right? It gives you a sense for where the regression line goes, what values are overestimates, what values are underestimates. But it's also a real quick way to check that you found the right regression line. Because if I plot this regression line and I made some sort of error in entering my linear model, what's going to end up happening is that the regression line I plot is not going to look right. It's not going to look like a line that goes approximately through the middle of the points. So the command here is actually really straightforward. You have to have already created the plot. So let's actually do something. Let's pretend we didn't have this scatter plot. Let's erase it. So I cleared the plot, so it's gone. What I need to do is I need to plot my variables again. So I need to plot x and y first, and then I need to tell it to add the regression line, and the command here is AB line, and then I just say model, because that's what I defined this thing to be. I called my linear model of this relationship model, and I'll click enter, and it'll draw in the line. And that line goes right approximately through the middle of the points, and that leads me to be pretty confident that what I came up with was correct. One of the huge mistakes that I see, it's really easy to make, and everyone makes it at some point, is either in your plot or in defining your model to put your variables in the wrong order. It's a really easy mistake to make. And if you put them in the wrong order on the plot, that's really easy to check because the plot gets labeled, right? I have sales here on the y-axis. That's what I wanted. I can check that. If you mess it up plugging it into the model, it's less obvious when you're staring at this output. But if you had put things in backwards, when you tried to plot the regression line, it might not even appear on your graph, right? It might not even fit there. Or actually, that's not true. It would have to appear on your graph because it would go kind of through the middle of the data. But no, it might not appear on your graph. Sorry, I'm confusing myself. it'll either not appear in your graph or it'll appear in a spot that doesn't seem right. Like it doesn't really go through the center of your data points. So it's a nice little check that you've got the regression line right. Okay, so hopefully that's a good spot to get you started into using R to pretty quickly get some of the basic outputs for regression to allow you to answer some of those questions where we're trying to take a relationship between variables and make predictions and some other things involving correlation, R squared, that sort of stuff. In a separate video, I'll address how we actually do the hypothesis testing and confidence intervals where we're going to use this other output here, these t-values and p-values and so forth.